Well, sorry about this. You missed the entire introduction of what E is. I would say if you're watching this video, you might have to Google what E is. I'm going to start using it.
You're going to lose subscribers.
And there's a lot of people absent right now, so hopefully they are watching this video, and we'll just come ask Mrs. Criswell what E is, and I'll tell you individually. Sorry, I forgot to hit record. All right, so e to the third multiplied by e to the sixth is e to the ninth. B, we've got 16 e to the fifth divided by 4 e to the fourth. Remember, treat your numbers separately than the e with the base. So we just divide 16 by 4. And then we do e to the, what do you do when you're dividing them? So then we have 4 e to the first. This one we're squaring. You have to square everything in there. That's the same thing as like writing it twice. So I would multiply 3 times 3, 9. And then what would I do when I multiply e to the negative 4x with another e to the negative 4x? When I have the same base, but I'm multiplying, what do I do? Add exponents, but what do I do to the base? Keep the same base, add my exponents, so I'm going to add negative 4x plus negative 4x. So negative 8x. Now, when we were doing exponent rules before, I was telling you can't leave a negative. So you would change that. But when we actually go to graph it, we want it to stay negative. So it just depends on what you're using this for, if you would have the negative exponent or if you want the positive exponent. Today we're going to be graphing them with the negative exponent. So here's a few more student practice. Let's do them together. E to the negative 9 times e to the 12. Keep the same base. Add your exponents. E to the third. Divide 25 and 35. 5 over 7. Now what do we do to the e's? Same base. Subtract the exponent, 2 minus 7. So you would either have 5 over 7 e to the fifth, or you could have 5 sevenths e to the negative 5. It just depends on what we were using it for. It's just simplifying. You might as well simplify to put the e on the bottom. 3. I'm multiplying and I'm doing power. What do I do first? Power or multiply? Multiply or power? So am I going to write this 5 times? So there's a shortcut. What do I do to everything in here? There's a garbage right there if you don't want it. What do I do to everything in there? Take everything to the fifth power. So I'm going to take 2 to the fifth. But how do I take e to the negative 3x to the fifth? What do I do when we have power of a power? We multiply them. So we get e to the negative 15x. So now I'm just multiplying. I can multiply the 2 to the fifth with another 2. What do I get from multiplying by 2's? I'm not multiplying the e's, so there's multiply here, and there's multiply here. I get 2 to the 6th. Remember, I add my exponents, which eventually I'll simplify down to 64. Now I'm multiplying the e's, so I'm going to add the exponents. I'll have e to the negative 15x plus x plus 1. And then I'll simplify that and get e to the negative 14x plus 1. Just using your basic exponent rules. How about this one? Root. How do we do roots? Just did this last week. So long ago.
So you consider a fourth power?
Not the fourth power, like the 1/4 power?
Oh,
Is that what you mean?
yeah.
Well, you would do that if you were solving, but there's no equal sign, so we can't do that. How do I just simplify when I've got a bunch of stuff underneath the root? What do I put under the first one? 4th root of. What do I put under the first one? What am I separating out? 16. And do we know the 4th root of 16? What to the 4th gives me 16? 2. That part's done. Now I'm going to separate out the 4th root of e to the 24x. How do I simplify something like this? Tree. How do I simplify something like this? Take it. It is to the 4th root. How do I make it so it simplifies the exponent? See how many times 4 goes into 24. I'm going to rewrite it as exponential, as a fraction. And how many times does 24x, how many times does 4 go into 24x? 6x times. So we have 2 multiplied by e to the 6x. Our final simplified answer. All right, so you have a section of your assignment where you're just simplifying stuff. The next section of your assignment, we're going to be graphing. And there is a function right here, y equals a times e to the rx, that you're going to need to determine some information. So since e is already a number, what number is e? 2.718. Since it's already a number, normally like with exponential growth or decay, we just look at that number, but it's going to have other stuff up there that's going to affect that. So what we do is we look at this r value. This r value, if it is positive, it's going to be growth. If that r value is negative, it's going to be decay. You can't look at e, because e is always 2.718, that never changes. You have to look at the variable that's up there, or the number that's up there with your x. And then we should know what growth and decay look like. We just did a graphing assignment 2 assignments ago where growth always goes way up fast, and then decay goes slow. So here we're going to tell if the function represents exponential growth or exponential decay, and we're going to graph that. So we look at 3 times e to the x, and to tell if it's growth or decay, you have to look for the r value. The r value is whatever is multiplied by the x. What's multiplied by the x? 1. So is that positive or negative? So this is growth. Now we are taking 3 times e to the x, and e is 2.718. Not the easiest thing to do by hand. So go ahead and type it in your calculator, but we're still going to accurately graph, and there is still an asymptote. So go ahead and type that in your calculator, and then I'm going to ask for ordered pairs that I can plot from you. And I'm going to ask you to find the asymptote. So go ahead and drop it on your calculator. So you're going to grab it on your calculator. Where can you find ordered pairs? Table. Stuart, can you give me an ordered pair, any ordered pair that I'll put on my graph?
0, 3.
0, 3, excellent. It's an easy one. Natalie, can you give me another ordered pair? What are you trying to find? Oh, they're all decimals. So give me an approximation. 8.2. I mean, how accurate can we really graph it, right? I just know it's a little bit over 8, and that's as far as I can graph accurately at this point. Duncan, give me another one.
360.35.
Is that going to fit on my graph? Okay, give me one that fits on my graph.
-1, 1.
Okay, -1 and then 1.1. Okay, and as you guys are graphing, you should be able to determine an asymptote. Timothy, where do you think the asymptote is? Look at your graph. I'm not asking you to tell him. He's a big boy. Now, you don't know how to tell me an asymptote because you're not doing your work. And this stuff's not going to magically be able to happen if you don't do your work. But we are getting into the hard stuff in Algebra 2 now, just so you know. Chapter 6 is okay. Chapter 7 is hard. This is not the time to be slacking off. 3, do you know?
1, 0.
Or read.
I thought it was like, I swear to God.
That's all right. I'm getting it. I said Bree, and I get what you said. That's all right. That's all right. You can tell me. I'll ask her. I didn't listen because I was listening to her. What'd you say? Y equals 0. Perfect. So I'll graph at y equals 0, my asymptote. And then when I connect my graph, I know that's the asymptote, so I'm not going to go past it. I'm just going to get closer and closer and closer to it, but I'm not going to go through it. Oh, sorry, 3, then second. Okay. Yep. That's okay. That's a good question. All right, here's the next one. Go ahead and graph it. Then I'll call on people for questions. But I'm picking the people. Oops. Shay, can you give me an ordered pair? 0.
Oh, 0, 1, 1.
0, 1. Aiden, give me another one.
2.
I couldn't hear what you said, Joe. 0.3? Oh, like this. All right. Emma, can you give me one? Okay, so after 3 ordered pairs, I feel like I don't know enough about the graph, so I'm going to keep looking for, I'm going to keep asking for more ordered pairs until I feel like I can actually graph it better. All right, Brianna. -4, 7.3, is that what you said? 4, 7, 3. That helps a lot. So now I can kind of have a place to draw it through. All right. And Zaina, can you tell me the asymptote? It's an equation, so 0 is part of it. Y equals 0. And you know why? Well, one reason, and you just don't know yet because you haven't done it, but one reason why that equation part is important is because when we start to do the inverse of these graphs, remember x and y switches. So we're going to have an asymptote at like x equals 0 when we switch it. So it's really important that you understand which one's y equals 0 and which one's x equals 0, not just 0. Plus it's a 1, so that's the equation. Oh, and then I never said if this was growth or decay, but we were supposed to do that. So is this one growth or decay? Decay, right. Because of the negative, so it's decay. All right, we have one. Well, if this is a graph, and we're not going to graph these because I didn't give you graph paper, but you'll graph them on your homework. Just say if it's growth or decay. So the first one, growth. Middle one, decay. And number 6, growth. Good. All right, the last example has to do with interest. So you could do compound interest like monthly, like we did in our homework. You could compound interest daily. You could compound interest hourly. You could compound interest every minute. What's something smaller that we could compound interest every second? What about smaller than that? Millisecond? What about smaller than that? I don't know what it's called either, but what happens is at some point you are compounding the interest what's called continuously. So you're like getting closer and closer and closer to doing it continuously. As soon as you're compounding interest continuously, we have a different formula. And this is the formula called the PERT formula. PERT. This is P, which is our principal, our initial amount, multiplied by E to the RT. PERT. PERT. This is for compounding continuously. So here is example that shows your friend's bank account, and you also have a bank account, but you don't have a graph, you instead have an equation. The two questions, we're going to compare your bank account equation with your friend's graph. And the two questions, the first one is, which account has a greater principal? Which account has a greater principal? So let's start with thinking about what principal is. So what's the principal? What is it? Like, what does it mean? Principal. The what? You don't know what the P is? Yeah. The base amount is the amount that you started with. The initial amount is your principal. And that's not like a word I'm only using in math class. That's like a word that is used in financial situations. So it would be an important word if you ever go into anything financial or have a bank account. Okay. Principal. That's the amount you put in. How much money did you put in? $4,500. From the equation, it's that big number right in front. You put in $4,500. How much did your friend put in? 4,000. That's their starting amount. At 0 time, your friend put in $4,000. So who put in more money? You had a greater principal. Second question is, after 10 years, who has more in their account? After 10 years, who has the higher balance? So after 10 years, you or your friend. So we're going to use the equation for you. After 10 years, we're going to do $4,500 multiplied by E to the, and I'm using the formula they gave, 0.04 multiplied by 10. So on your calculator, you do not need the graph to find this answer. On your calculator, you can just use the calculation screen. 4,500, and then do that e to the x, and then do 0.04 multiplied by 10. So $6,713.21 would be your balance after 10 years. 6713221. How are we going to get your friend? Because we don't know their rate. How did I do what? The equation. 4,500 multiplied by E to the, and then in the to the, I put 0.4 times 10. Got it? All right, how do we find your friend for 10 years? Can we just look at the graph at 10 years? How much is that? Over $7,000. Who has more? Yeah, and that's all you really need to know is that they're over $7,000, which is already more than you. So friend has more after 10 years. That's higher balance. So next week, we're going to learn about the inverses of exponential functions and of the natural base e. We'll learn about the inverses of that. So if you don't know how to do the regular things, you're going to be totally lost next week. So please use the rest of your time, which is 12 minutes, to work on your assignment. I have graphs for you, and then I have books in here that you can borrow. But I have graphs for you so you can, use your graph paper for the graph part. So go ahead and grab a book, take a picture of it, or borrow it during class. You don't have your own. And begin. There's 8 graphs. Nobody did have to grow.